These problems involve using the equation delta H of the reaction is equal to the sum of the delta H of formation of the reaction of the products minus the sum of the delta H of formation of the reactants. This particular equation is a little confusing if you aren't used to mathematical symbols or haven't used it before. So before we actually do these practice problems, I want to break down sort of how we use this equation. So let's say we have a reaction, AAs reacts with BBs to make CCs and DDs. In this particular reaction, we could then rewrite the equation above. The delta H of the reaction would be equal to the delta H of the products. So the products are C and D. The products are C and D. So the sum of the products would be the delta H of F of C times how many there were, which is the lowercase c, plus the delta H of F of D times however many D's there are. That would be the sum of the enthalpies of the products. And then this whole thing would be minus the enthalpies of the reactants, which would be A and B. Sorry, I had to squish that in a little bit there. So we are trying to add these up. All right. So let's move down and actually apply this to a problem. Oops, okay. Give me a second. I got to clear the screen. Okay. Now we can apply this to a problem. Ugh, sorry. Undo. There we go. So we're looking at the reaction. Calcium chloride solid dissolves into Ca2 plus aqueous and Cl minus aqueous. Hopefully, maybe you noticed that this equation isn't actually balanced. So when CaCl2 dissolves into water, it makes one calcium ion and two chloride ions, one calcium ion and two chloride ions. So there, now it's balanced. All right, so we are going to first look up in the back of your textbook. You can find these in the appendix, or if you're doing a lot of work with these, you might find it helpful to find a table of these online somewhere and just print them out if you don't have a loose leaf or hard copy version of the textbook, because otherwise you're flipping back and forth a lot. Okay, so when I do these kind of problems, I usually look up all the values first and then start doing the math. So for calcium chloride, the delta H of F value is negative 795.4. For calcium 2 plus aqueous, when you look it up, make sure you are looking at the phase too. So calcium aqueous is negative 542.8 and chloride aqueous is negative 167.2, and these are all in kilojoules per mole. Okay. So now we're going to plug these values into the equation. The delta H of the reaction is equal to the sum of the delta H's of the products. So the products are the calcium ion and the chloride ion. So it's negative 542.8 kilojoules per mole times 1 calcium ion plus negative 167.2 kilojoules per mole times 2 chloride ions. That's going to be the sum of the enthalpies of the products, and this whole thing will be minus the sum of the enthalpies of the reactants. There's only one reactant, negative 795.4 kilojoules per mole times 1 calcium chloride. When we put the 1 calcium, 2 chlorines, 1 CaCl2 into this problem, what we're actually representing is a little bit more complicated. And I'm only going to go through this once so you can see how the units here would work out. What we're actually saying is there is 1 calcium chloride in 1 mole of reaction. So actually, let me get this a little bit more correct here. What we're really saying is that there is 1 mole of calcium chloride in 1 mole of reaction. And so this is canceling out with this mole right here, which is actually 1 mole of calcium chloride. So what happens to our units here is the 1 mole of calcium chloride cancels out, and our units are now in kilojoules per mole of reaction. So what we're doing is we're switching from kilojoules per mole of the substance to kilojoules per mole of reaction. And so that's happening for each of these, and our unit works out to be kilojoules per mole of reaction for everything in this equation then. That's a lot to write out though every single time. So most of the time we just write it out as this sort of simplified version here, and what we have to remember is that it represents this whole process here. All right, so now we have to start plugging into our calculator. It will work out to be the products part works out to be negative 877.2 kilojoules per mole, and the reactant side works out to be negative 795.4 kilojoules per mole. When you combine those, that gives us a final answer of negative 81.8 kilojoules per mole. That would be the delta H of the reaction. All right, this is negative. What does that tell us? It tells us that this is an exothermic process. And you might actually be familiar with this. Calcium chloride is one of the salts that they sprinkle in on ice to prevent it from freezing. So when you sprinkle calcium chloride on the ice, it heats up as it dissolves, and that helps melt the ice as well as lower the freezing temperature of the water.